Now, if you are logged into Slack, you may have noticed I've just published, was that with G or with another group? No, I think I published a message there earlier on today about enrolling in uh, on Moodle. So hopefully it should work for you now. And as well, as you know, the current lab that you're working on, the TypeScript lab, the hand up date was meant to be tomorrow, but I've extended that to Friday week. So you've got plenty of time to finish off that lab. But first and foremost, you can enroll. Now, there's nothing when you do enroll, there aren't really any resources there that you can use other than uploading assignments. There are no slides or anything else there. It's all really in the website. So I want to finish off the TypeScript overview with you today. And as well, I think we'll have a little bit of time to start into something called the CDK framework. Both TypeScript and the CDK framework, I would consider them, both of them, foundational material for this module. Kind of by that I mean, once we have those two skills or those two technologies as part of our skill set, then we can start doing proper distributed systems material. So the first thing I will look at will be the serverless architecture, for example, but that will be for next week, I'd say, at the earliest. So let's continue on looking at these slides here. And what we know about TypeScript is that, first and foremost, it is a compile time language. It's not a runtime language, and it compiles to plain old JavaScript. Essentially, it's kind of JavaScript with type uh, a type system imposed on it. So you have to a statically typed system imposed on it. So you have to upfront you have to declare the type for each variable that you use in your code. You either declare it explicitly or you let the TypeScript compiler infer a type on it. Now, if the type that it infers is not what you want, then you can override that. But so that's the first part. It's a compile time language. Um, and from a syntax point of view, I guess if we start here, from a syntax point of view, the first thing you learn about TypeScript is in terms of declaring the type for a variable, you use this postfix syntax, which is this syntax here. The next thing we mentioned was that TypeScript supports classes. Didn't talk much about that because we know a lot about classes as a programming construct, and the syntax is just pretty straightforward. Similarly, for interfaces, didn't talk much about that, but again, it has the same meaning and almost syntactically, it's very like interfaces in Java. Interface data types then was a new feature, I guess, if you like, from the language. And what interface data types or IDTs allow us to do is to declare the structure or shape for any data object. And we looked at the syntax for that here, and then using it here. Type aliases overlap to a degree with interface data types, but type aliases have a lot more flexibility to them, and we'll see a little bit of that today. Type inferencing is this kind of sweet spot, as I think term I used last week, which is that you let the compiler determine or infer the type for a variable if you don't do it explicitly. And I guess I should also say, I don't know if I said it the last day, is the more experience you get with using the TypeScript language, the more you let the compiler work its type inferencing on it. But we are only going to be programming TypeScript for a couple of weeks, so I wouldn't put you in that category of being experienced TypeScript programmers by the end of the module. So you will find yourself, the more TypeScript programming that you do, you'll find yourself not being explicit about your types for your variables. You let the compiler do it. So you have physically less typing to do on the keyboard, and therefore your productivity increases. Functions, in relation to functions, we know what a function is, but from a typing perspective, you need to declare the types of the parameters of a function, and you can be explicit about declaring the return type, or you can let the compiler infer the return type. And the latter is what you would do quite a lot. This is roughly then where we left off. Higher order functions. The point here is we're still talking about functions, but the characteristic of one of the characteristics of higher order functions is that one or more, but typically only one of a higher order function's parameters is itself a function, as we have in this example here. And so we need to know, from a syntax point of view, how do we declare the type for these function parameters or callbacks? And so this is the syntax that you use here. This syntax, as I said, is essentially declaring the signature type. What are the types of the parameters? What is the type of the return value given by the function? All you're doing here is declaring its signature. When you actually invoke this higher order function, then what the compiler will do is, and of course, when you invoke this function, you do, in this particular case, you need to pass two arguments. You need to make sure that the first argument is a string, but you, as the programmer for this particular example, you've got to make sure that the second parameter is a function and that that function respects this signature here. If that's not the case, of course, the compiler will tell you that the function that you're actually passing when you're invoking this is violating the type that you've declared here. And so if we flip over to the code that's accompanying these slides, and you have access to this. So if we go into the functions folder here, sorry, not that one, this one. And we've got a section, or I've got a section on higher order functions. Okay, that's the one we looked at in the slides. Here's another example down here. I'll just talk to this one. So I've got this function, which I'm calling an array mutator. And the idea is you pass it an array of numbers, and you also pass it a callback, which I've called the mutator argument. And the idea is that the function, this function here, it takes this array and it returns an array of numbers where each of the numbers in the return array is determined by looking at the corresponding number in the source array and modifying it based on this mutator function. And you can see that's kind of doing in the body of the function here. It's a simple one-liner. Okay, so I'm taking the source array, I'm mapping over it, and I'm calling my mutate function. Therefore, it's going to make a change to every element in this array and return the result. It doesn't modify the source array, as we know. So from a higher order functions perspective, this argument here has to be a function, and it has to be a function that takes a number and returns a number. Yeah, and for example, I'm calling it here. So I'm passing it my array of numbers, and this is the mutate function. So all it's doing, it looks like, is it's multiplying each number by 100. But the part that I've highlighted there, that's a function, and that function is it's respecting this signature up here. So the compiler won't complain. I'm invoking it, invoking a second time down here. So first of all, what I'm doing here is I'm just declaring a simple function for myself. And it's a function that takes a number and it does this computation. It looks like it's checking to see if the number is greater than 100. If it is greater than 100, it decrements it by 10%. Otherwise, it just returns the number itself. So this, what I'm calling it, a selective decrement function, that function it has the same signature as our mutate. So we could use it, and that's what I'm doing here. I'm calling the select mutate, or I'm passing the selective decrementer function to my higher order function. So both of those work fine. You know, if I did something silly like, let's say if I said here, if n is greater than 100, then let's say return true. Yeah. Boolean true. Otherwise, return the Boolean false. Of course, from the compiler's point of view, that's not good. And we can see our, where is it telling us? Is it complaining? It should be complaining. Syntax error there, sorry. We've got the kind of red squiggly line in my case, and it indicates in my VS Code, that's telling me there's a compilation error. And again, if we look at the problems tab and examine what it's saying, essentially what it's saying here is that the type of this argument, which is, it's a function. I mean, let's do it here, right? If we do Command K, Command I, it's a function that takes a number and returns a Boolean. Yeah, that's what it's saying there. Bring it up again. Takes a number, returns a Boolean, and of course that's not what we should be passing to our array mutator, and that's why the compiler is complaining. So the compiler will drill down any number of levels to make sure that you are honoring the various types that you have in your code. Let's just undo that. Okay, optionals is the next thing. Oh, sorry, I just remember now what I was, sorry, let's go back to here. I just remember what these examples were about. Yeah, I'm just using type aliasing. So like what I'm doing here is declaring, I'm using the type alias syntax. I'm declaring a type called mutator function, and I'm assigning it, a function signature. And then I'm using that type here. So the only difference is right between what I'm just showing you right now and what we had before was that before we had the actual signature here. But now that I declare the type for myself, because if the signature that we had here was a signature that we needed to use a number of times, then there's just physically more keyboard typing to do. So by declaring a type for that function signature, then we can use that type wherever we need to. For example, we're using it here. But other than that, the code is the exact same. So that's where this type aliasing really becomes extremely useful, even though we've only touched type aliasing so far. But you see another example of its usage in what I'm showing you there in the code. And this example here, I'll just stay with it. So I've got a function. Again, it's a pretty, I've got a function that takes a string, which let's supposing it's a URL, and it returns a promise of a string. Okay, so the whole area of promises is obviously built into the TypeScript environment as well. And if we look at the body of this function, okay, it's just a one-liner, but that's what it is actually doing. It's returning. Let's see. Okay, this example here, yeah. It's returning a promise that resolves to a string. Oh yeah, sorry, I mixed up the two examples. I beg your pardon. Okay, let's start again. Here's a function. It takes a string as an argument, but I'm not actually declaring the return type of this function. Okay, even though when we look at the body of the function, we can see that it looks like it's returning a promise of a string. Yeah, and so if I do Command K, Command I, will the compiler infer the correct return type? And it does. You can see there on the right, it infers that the return type is a promise of a string. So the compiler understands promises. I guess that's the point I'm trying to get across here. Here's another example of it. I've got a function that takes a string and sorry, can you still hear me? Can somebody confirm?
Yeah.
Yeah, it dropped on my side there for a second. So, okay. I think I'm on a reliable, let me just check the network to see, are we on a reliable network? Just give me one sec. Looks okay. Okay. Don't know why it dropped. Let's go back to here. Okay, I was kind of stumbling through this code, but we were about here, yeah. So I've got this function and its signature is that it takes a string and returns a promise of a person object. We had person defined last week, if you remember. And if we look at the actual code, we can see that it is returning the promise, and I'm just instantiating, hard coding a person object here. So, the whole area of promises are understood by TypeScript as well, and it kind of builds it into its whole type system. Okay, back to here. The next thing is optionals. It's a pretty straightforward thing, really. It relates back to interface data types. The idea of optionals is if you have an interface data type, but you want some of the properties to be non-mandatory, i.e. optional, then how do you declare that? And so it's this question mark symbol here. So the way you interpret this interface data type is the ID property, every instance of a user object has to have an ID, it has to have a name, it may or may not have an email, it may or may not have a social structure. And the way you interpret what's going on here is if it does have a social object within it, that social object must have a Facebook property, but optionally it can have a Twitter and optionally an Instagram property. And finally, it has to have a status property. Okay, so some of the properties of this user interface data type are optional. And you can use this optional symbol, the question mark, with function parameters as well. Do I have an example of that? Looks like I don't, but let's go into the code. And if we go into the optionals folder, pretty straightforward concept, I think. But here's our user interface data type that we had from the slides. And then I've just got some examples of user objects. So Joe doesn't have an email, does have a social property, and within that has the Facebook property, which is mandatory, okay, but doesn't have the others. So there's no compilation error happening here. So the compiler knows that, even though there aren't emails and Twitter handles and Instagram handles, that's fine. Jane looks like she does have an email property, but doesn't have a social property. And finally, Jill has an email and a social property, which has two sub-properties within it. Okay, so that's fine. That's the optionals feature. Pretty straightforward, I think. Going back to the area of type aliases, and there are two use cases for the type alias syntax. We've actually seen them already, but I'm kind of introducing them formally here. There's this notion of union types and type literals, two different things, but they all come under the umbrella of the type alias syntax. So what are union types? Union types is a type whose values can be of more than a single type. Okay, too many uses of the word type there, but an example hopefully clarifies it. So I'm declaring a type, and remember, type now is just a custom. It's a custom type for a particular application that you might be working on. Each application has its own custom types. So anyway, I'm declaring a type called size, and I'm saying that objects of or variables, variables of type size, they could be a string or a number. Here's some examples. I'm declaring a variable here called glass size. I'm saying it's of type size, and I'm assigning it a string. So the compiler is happy with that because that's respecting this. Down here, I'm declaring another variable called bottle size. Its type is size, but this time I'm assigning it a number. And the compiler is happy with that as well. So what we would say is that this size type here, we would classify it as a union type. So that's union types, and there are lots of cases when they're very useful. Literal types is where you're actually restricting the range of values of the type to very specific values. Again, an example hopefully makes it a little bit clearer. So I'm declaring a type here called degree nomination, and I'm saying its values are only these specific values. So if I ever declare a variable of this type, that variable can either have the value of the string BSC or BEng or this or this. Here I'm declaring an actual variable. I'm saying its type is this, and I'm assigning it BEng. And so the compiler would be happy with that. So that's so we would say that this degree nomination type here is an example of a literal type. Don't think there could be much confusion about those, but I do have some stuff going on here as examples. Okay, that's print ingredient. Oh, the print ingredients function. That's just going back to, sorry, going back to optionals. I've got a function here called print ingredients, and I'm saying it takes two arguments. The first argument is a string. The second argument is also a string, but I'm saying it's optional. I'm not saying it's optional. I'm saying it's mandatory. The third argument is optional. Okay, so this function can be invoked either with three arguments or two arguments, and the function will work either way. Of course, you've got to make sure within the body that it does work. But all we're doing in the body anyway is just doing a console log, so there's nothing intricate going on there. Here's a question for you. I'm not stating the return type of this function. What do you think is the return type? Is anybody brave enough to volunteer an answer orally? No. The return type should be void. Command K, Command I. And there over on the extreme right, its return type is void. You know, if you've got a function that doesn't explicitly return anything, that's what the compiler infers. But from an optionals point of view, this parameter here is optional, and I'm invoking it then here and here. In this case, I'm invoking it with two parameters, and in this case, I'm invoking it with three parameters. Sorry, now I know I'm going back to the thing about optional function parameters is that you can only have them at the end of the parameter list. So in other words, what you cannot do is the following. Not that, sorry, wrong key sequence. What you cannot do is this. Okay, I'm saying the first argument is mandatory, second argument is optional, third argument is mandatory. And the reason we're getting a squiggly line here, and if we looked at the explanation, it's essentially saying is that a different, sorry, that's a different, sorry, no, I need the comma here, of course, from a syntax point of view, but that still isn't going to, and it's saying here that a required parameter cannot follow an optional parameter. Okay, so you just, it has to be at the end of your parameter list. Bring that down, get rid of that. Okay, that was back to optionals temporarily. Back to our union types and type literals, just another example of them really. So I've got a social handles object here, sorry, type. I've got a social handles type. I've got an address type. And then I've got a union type here now called contact, which is of either that or that. And then I've got a user type. I'm not using type aliases in this case. I'm using interface data types. You can mix and match interface data types and type aliases as much as you want to. But for this user version 2, you can see here that one of the properties, its type is contact. And we've set up here contact could be a that or a that. So you're getting to see now how we can, you know, use custom types within other custom type declarations, and that's what we're doing here. And then eventually we've got some examples of users of type v2. So Kyle has a contact property, which is mandatory, but looking at the shape of the contact, okay, tells me that it's a social handle uh, contact, whereas Jenny has a contact, but its structure follows the address structure. And finally, okay, there's only two examples. I'll pull this down a little bit. There's something else interesting that I can show you here now as well. So let's supposing I've got this function called getContact. And the idea is you pass it in a user. And what I want it to return is the user's contact details just as a string. You know, it stringifies the user's contact details. Okay. So what I need to do though is I need to check what type of contact does the user have. Is it a social handle or is it an address? Let's suppose there's a good reason why I need to determine one from the other. Well, I suppose there isn't since it's what I'm returning here. So I check to see if street is contained within the contact property of my user parameter. And if street is, then that must mean that this particular user's contact property is an address structure rather than a social handle structure. And then I'm returning, you know, this nice string that says, look, the address is whatever. Now, the point I'm trying to get across here, though, is the following. If we look at this statement here, I'm assigning user.contact to just a local variable. And again, I'll ask a question, even though you're not great at volunteering answers, but I'll ask the question, what type is that variable, this contact variable here? What is its type? Well, you might say, well, its type is, if I look back up at the structure, its type is contact. But we know that contact could be either a social handle or an address. So is the compiler able to work out whether a contact is either one or the other? Is it intelligent enough to work that out? Because programmatically we are actually this if statement is essentially trying to determine, is the contact of this user, is it an address structure or a social handle structure? But the compiler is actually able to follow this flow of control as well. And so if I go Command K, Command I on this, it actually works out that it's actually of type address. So it can follow, the compiler can follow the flow of control in your code and make similar inferences to variable types. In this case, it has inferred that really the actual type of this variable is of type address because of the nature of the if statement that precedes it. And again, if we follow the flow of control, so if the flow of control is such that this if statement is false, so it skips over it, and we make a similar assignment statement here, and again, if I go Command K, Command I, so the only time the flow of control would execute down here is if the user's contact was not an address, i.e. it didn't have a street contained within it. That must mean that the user's contact is of type social handle. And to prove it, Command K, Command I, that's what the compiler works out as well. That's a pretty sophisticated aspect of the compiler, but I thought it would be worthwhile just showing you something like that. This is the term that we use to describe what's going on here is type narrowing, in that at this stage here, like if I put in a line of code here, let's say, in fact, if I just do this, right, if I copy this line of code and bring it up here. And I'll just call it something else. Now, from a flow of control point of view, at this line here, we don't know, and the compiler doesn't know, is contact2 of type address or is it of type social handle? It cannot determine it. And if we do Command K, Command I, it's telling us, look, it's of type contact. That's as much as it can work out. Whereas, as we saw, once we get inside the if statement, it knows and we know that the contact is of type address. And similarly, once the flow of control gets to here, the compiler knows and we know that the contact is of type social handle. It can't be anything else. If it's something else, then we would have got a compiler error much earlier. Okay, there's quite a lot going on there actually, but either way. Let's move on down to an example of literal types. So this is the example. Oh no, it's slightly different. We've got a department type, and I'm saying it's either this or this or this. And then we've got a staff member and a staff member. I'm declaring a type here now. Staff member type is essentially a user type, but I'm adding on an extra property. This is again another little technique that you can use in TypeScript. I'm ANDing this structure with this structure to give me a new structure, and I'm calling that new structure staff member. So a staff member has a department property, is a user with a department property. And I've got a company variable, which is an array of staff members. And you can see each member has all of the properties. Jenny and Kyle were two users that we declared earlier on. So we're just spreading out using the spread operator on their properties, and we're adding on a department property. So this entire structure here, this entire line here, this entire structure is a structure of type staff member. And then I've got a function which, let's supposing I pass it in a department value, which can either be engineering or science or sales or accounts. And it's meant to kind of return back. What I wanted to do is return back the name of every member of staff that's in this particular department. And that's really what's going on here. Yeah, you can look at that later on yourselves. So that's literal types and union types. The next topic is generics. The first language to introduce generics, to my knowledge anyway, was the Java language. And we're talking about actually a number of decades ago. A number of languages have generics now, though. Kotlin has it, and probably a lot of languages have generics. But the idea behind generics is it's all about reusability. And we want to make it's about enabling you to make components within your code reusable. Now, components in this case could be anything. It could be a function, to make a function reusable for different, reusable for different data types. That's the key point. Generics is about enabling reusability of components within your code such that they can be used with different data types. And a component could be a class or a function or an interface data type or a type alias. So it really spans right across all of the different constructs that are available in the language. But the key thing to remember is we're talking about reusability in the sense of being able to use the component with different data types. So with a generic declaration, you have variables, right? But the variable in this case is instantiated with a type. Typically, when we talk about variables in programming, we assign values to variables. But with generics, you have variables that are assigned a type, and then uh, it retains, and then you can declare variables with that type. But the type is actually passed in as an argument, if you like, to the component, whether that be a function or a class or an interface data type. Here's an example, and again, it's the syntax that you'll probably recognize. If you've done any Kotlin programming, you'll recognize the syntax. But here I want to make this particular function, which I've purposely given a generic name. They don't ever call a function process because it doesn't mean anything. So I've got a function, but whatever logic is implemented by this function, I know that I want that logic to be applied to different data types within my application. And so rather than writing a version of this function for each data type, I can actually leverage generics. And this is how we indicate that we're using generics. So this angle bracket, close angle bracket, T here is what I'm calling my type variable. And it doesn't have to be T. You can call the variable anything you want to. It's just a convention. And also there can be more than one type variable. So you could have a comma and another variable name all within these angle brackets. And so T now is a type, but it hasn't been assigned an actual explicit type yet. And you can see I'm using T here. So I'm saying the first argument is of type T, whatever T will be. Could be a person, could be a string, could be a user, we don't know. And the second argument is a number, that's okay. Now I'm not showing you the body of the uh, function because we don't need that detail. So this is my function declaration. And here I'm actually invoking the function. And it's when you invoke the function, that's when you determine or you state what type T should take on. And so it looks like here, I want my T variable to take on the person type, which presumably I've declared somewhere else. So presumably this person X is a variable that I've declared somewhere within my script, and person X will be an object of type person. Otherwise, the compiler is going to complain. I'm invoking the same function with a box type, which again, presumably I've declared somewhere. And presumably this variable here is pointing at an object of type box. So the syntax anyway for generics is this angle brackets. Let's look at an example of this at play. We go into the generics folder. Now I'm kind of building up the example, hopefully for clarity, but you can determine whether it's clear or not. So first of all, in this script here, we're not using generics at all, right? I'm explaining the context for the use of generics, which will come later on in this script that we're looking at. Let me just collapse. Let me collapse that. All right, now getting my keyboard shortcuts incorrect. Okay. So first of all, I've got an array of strings, and I'm calling the sort method on my array of strings. And as you know, from your JavaScript, the sort method takes a callback, and what the callback does is it kind of determines how the array should be sorted. And so it looks like in this case, I'm using the linked of my strings to determine the sort order. And as you know, this function here, it has to return a numeric value. And if that numeric value is negative, then it knows that A and B within my array should be swapped because A is, in this case, longer than B. If this expression here returns 0, then A and B have the same, from a starting point of view, they have the same value, so they can remain where they are. If this returns a positive value, it means that B is greater than A, so you shouldn't do a swap at all. It does a bubble sort, in other words. Okay, so there's nothing new there. You've seen that before. You've seen and used sort before. Now, let's supposing I want to declare this function for myself. Again, there's no generics being used here so far. So I've got a string ranker function, and the idea is that you pass it an array of strings, and you also pass it what I'm calling the ranker argument. This is going to be a function, and the ranker function will be used by my sorting, because I am sorting within the body of this function, and I'm using you can see I'm using the ranker here to determine how my array of strings should be sorted. Yeah, and obviously this function has to take a string and return a number, and that's because of the way the sort works. Okay, this function here has to take a string and return a number. Okay, so that's okay, and there isn't really any further explanation that I think that I need to make of this guy. Again, there's no generics being used now yet. Sorry, I got that wrong. This function takes two arguments. No, takes one argument, sorry. Takes one argument of type string and returns a number. And the reason it has to do that is because of the way the sort works. Now, let's supposing I'm actually invoking it here. Yeah, I'm invoking it here. And I'm passing in this array of strings. And here's my ranker function. And I've decided to use linked as the criteria for the sorting, which is really the exact same as I had at the very first line. So we haven't really made a whole lot of progress. But I could have used some other criteria. Like I could have used maybe, here we could have maybe counted the number of vowels, and that would return a numeric value. And that could be used then for determining the sort order. But that's fine. And I'm just illustrating it here. But supposing as well, I've got a function that does the exact same thing, but this does it with person objects. Yeah. And just to remind ourselves, because I'm importing person here. And let's just remind ourselves of what a person object looks like. A person object has a first, a last, and an age. And I've just arbitrarily decided that age is an optional property. Okay, although that will be relevant in a few moments. Let's go back to my script. We still haven't talked about generics now, so this is a slow build-up, but bear with me. So here's my person ranker. Takes an array of persons, takes a ranker function. In this case, the function takes a person object but returns a number. Always has to return a numeric value because that's what the sort requires. And this is the body of the function. Now, of course, if we look at the body of this function, yeah, if we look at that and we look at the earlier one, they have the exact same structure. They're just dealing with different data types. One is dealing with a string, the other is dealing with a person. Can we bring those two together? And the answer is yes. And it's facilitated by the use of generics. I'm just giving you an example here of calling my person before calling my person ranker. So I've got some person object here. So Joe has these properties. Joe does have an explicit age. So does Jill. And I've decided that Jane doesn't have an age property. Now that is problematic though, because so here I'm actually calling my person ranker function. Again, there's no generics being used here, but there is something that I can show you uh, while we're eventually getting to generics. So here I'm calling my person ranker function. I'm passing in an array of person objects, and this is my ranker function. And it takes a person object. I'm using type inferencing. P is going to be of type person. And what I want to base the ranking on is the person's age. But the problem is I can't just go p.age like, sorry now. I cannot do just return p.age. Because you can see there's a squiggly line there. The compiler is complaining. So back here, I'm saying that the ranker function has to take an object, an argument of type person, and return a number. Down here, I could be explicit about P, that P is a person, but it's not complaining about P. What it's complaining about is P.age. But P.age does evaluate to a number. So why is it complaining? Because this looks like it's respecting the signature of my ranker function. It's taking a person and returning a number. So why is it complaining? And it's complaining because there are cases when P.age will be undefined, because age property in my person type was optional, as I showed you. So there will be cases when P.age does not evaluate to a number, it will evaluate to undefined. And now that is what the compiler is complaining about. And if we brought up the actual compilation or compilation error, it's saying type, number, or undefined, because P.age could be of type number or undefined. That's not assignable to type number. It's not assignable to what I wanted up here, which was number. Okay, and the reason I'm actually just showing you this as an example, even though we're meant to be talking about generics, but we haven't even mentioned generics so far. The reason I'm actually showing you this example at all is, I guess you would say that this is kind of an edge case. You'd imagine most person objects might have an age property, but according to my person type definition, age could be omitted. And so the compiler will always make sure that you don't write code that could potentially cause your application to throw an exception or crash. And the fact that p.age would evaluate to undefined, that would probably cause a runtime exception. In this case, if we were doing this in the kind of Java world, it would cause a runtime exception because the sort wouldn't be able to deal with undefined when it's trying to sort my array of person objects. And so the solution to that is, well, we've got to come up with a solution. But so my solution is kind of arbitrary, really. I decided, well, if a person object does not have an age property, well, first of all, if they do have an age property, then p.age can be the return value of this function. If they don't have an age property, I've arbitrarily decided return the value 30. Okay. let's suppose 30 is some sort of average age in this case. And so now the compiler is happy. Um, well, it's not, but that's probably because I've got a syntax error somewhere along the lines. Yeah, I think is it here? I just undo all the changes. Still unhappy. Let's see. Okay, now it's happy. Um, right. Eventually, we need to get to generics. That's what I'm meant to be talking about. So here we are. Let's solve this problem with generics. The problem being I've got this function here, which is just sorting person uh, objects, and I've got the earlier one, which is just sorting string members of an array. Can we bring them together? And the answer, of course, is yes with generics. So here we go. I've got a function which has got a terrible name, but generic ranker takes one type argument, which again I've decided to use t. The first argument is an array of t's. Second argument is a function that takes a t and returns a number. So t can be instantiated with either person or string or maybe something else. The body of my function is the same as before. Yeah, it's the same as before. And eventually then, here we get to use my generic ranker. In this case, I'm assigning person to t, and I'm passing in my array of person objects, and I'm passing in my ranker function that we had before, and the compiler is happy with all of that. Similarly, here, similarly but slightly different. Here I'm calling the generic ranker function again, but notice I'm not being explicit about what type t is. And this is another example of where type inferencing comes in. The compiler will actually infer that t is going to be of type string. How does it work that out? Because it essentially looks at this here. It notices that my array is an array of strings. And based on the definition of my function, the t array here, determines what type t is. And so if I have an array of strings, then that must mean that t is of type string. So type inferencing can apply with generics as well. In fact, if I go back to here, I could have actually left out person, I think. Let's try it. Where is this coming from? Sorry. Coming from somewhere else. Okay. Don't worry about that. I should really kill that. Sorry, that was just hanging around. So yeah, it's inferring person here as well. So I didn't really have to be explicit about it. Okay, that's an example of generics being used with functions, but you can also use it with classes, which we won't look at. You can use it with interface data types, and that's what I'm illustrating here. So I've got an interface type called microphone with these properties. It's just a standard interface data type. A standard, another one called speaker, nothing exceptional here. But then I've got a box, and I'm using generics here. Again, I've decided to use t, but I could have used any variable. I guess the idea is that I can have boxes. I can actually have box structures for different types of contents, being speakers or microphones. But a box has a shelf number, and it has a content, which is an array of keys. And here I'm declaring an actual variable called box1, and I'm assigning speaker to my T variable. So that means that my array here has to be an array of speakers. And if you look at the structures, you can see that they are, well, there's only one, but you can see that its structure is of type speaker. So that's generics being used with interface data types. You can use it with type aliases and all of the other constructs that we've looked at so far as well. I don't expect people to write generics code, but you will see a lot of generics code when we start getting into the AWS stuff that we need to look at. Finally, utility types. Utility types, these actually come with the language, although there are open source utility types out there as well. And what a utility type is, it's a way of transforming one type into another type. And again, examples, the screenshot is just from the TypeScript documentation itself. And there's a section on utility types, and it lists all of the predefined utility types that come with the language. And we'll just look at a small few of them. Back to here. And if we go into this section here, so I've got a tech user interface data type here. It's a standard, okay? And then this is where we see an example of the utility types being used in this line here. And in particular, we're using the partial utility type. It actually uses the generic syntax, but I wouldn't think of these as from a generics point of view. Although arguably, I suppose it is really generics because you can use partial for lots of other use cases. But here I'm using partial with my tech user. And what the partial utility type does is it creates a new type by transforming this source type such that all of the properties are made optional. Now you can see in my original, there's only one optional, which is email. But if I do Command K, Command I on this guy here, Command K, Command I, you can see all of the properties are optional. So there may be a use case where you want that. So that's the partial. And just I've got a little function here that's using my my new type, my tech, what do I call it? Tech user optional. You can look at that later yourselves. Here's another utility type called required. It's kind of the opposite of partial. What it does is it takes this source type and it transforms it into a new type. Well, it creates a new type. It doesn't make changes to the source type. But the new type has all of the properties of the source type, but they're all made mandatory. Now, in our original tech user, email was optional, but if I do Command K, Command I on this, you can see that email is mandatory. So again, there may be a use case in your application, but it's not made that there you wouldn't define it otherwise. There's a use case in my application where I want users to have an explicit email. And let's see. Yep. And I'm using it here in a simple piece of code, or am I? Sorry, I'm not. No, I'm not using it anywhere, but that's okay. Here's another utility called pick. And what you use that for is you want to take some source type, uh, but you just want to pick particular properties out of it and create a new type with those properties. Now, in this case, you kind of interpret this symbol here as and rather than or. So I want to create a new type, which I've called just, terrible name now, but just email and name. And that type is based on the tech user, but I'm just extracting their email and their name properties. And again, if I do Command K, Command I, you can see what that structure looks like. That's pick. And it looks like I'm using it here in a simple example. The opposite of pick is omit. Here, what happens is it takes this list here of this list of properties and omits them from this one. And the result then is what's contained in the new type. So again, if I do Command K, Command I, it has all the properties of user except ID and email. And finally, so we've looked at whatever 4 utility types. There are probably, not sure if there's 100, but there's certainly a large number of them. But the ones that I've shown you are certainly the most commonly used ones. Another one that's commonly used, and it doesn't fall into the neat kind of description of the other ones that I've just shown you, is the record. Where have I got it? Here, the record type, utility type. Let me just show you what I want to do first, and then we can maybe explain the type. So if I just run this script, so if I go back up, sorry, first to, do I have some users? Let's see. All right, so I've got an array of, what have I got an array of? I've got an array of tech users. Yeah, okay, an array of tech users. Are they tech users? ID, name, programming, ID, name, programming. Yeah. I've got an array of tech users. And what this function does is it creates a map, kind of a lookup map, where the keys of the map are the IDs of the tech users, and the values are objects of type tech user, are of type, sorry, I'm stumbling over this. They're of type, are they? Oh yeah, tech user map by ID. Is that what they are? Tech user. What is tech user? I thought I was using tech user programming. Just give me 1 second now. So I've got tech user map by ID. That's okay. Oh yeah, of type tech user programming. Tech user programming is where my objects, let's do Command K, Command I, objects with a tech user's name and their list of programming languages. Okay, so I want my function, I want this function to take in an array of tech users and return a map structure where the map's keys are the tech user's ID and their corresponding values are objects that just have that tech user's name and the list of their programming languages. Okay, I got there eventually. Let's just run it to see what the output looks like. So if I run,
I think you're muted.
well done. Every time you come back into Zoom, it mutes me automatically. Uh, Let me start here. Okay, well done. Thanks for whoever said that now. Okay, so here's what my function generates. It's an object where each entry in the object has this structure. It has a key and it has a value. The key has to be equal, the key's type has to correspond to the ID property of TechUser, and the value has to correspond to this here. Okay, and that, if I just do Command K, Command I, that looks like that. Okay, so from a typing perspective, how can I express that structure, right? And the answer is you can use the record utility type to do it for you. It's a fairly kind of sophisticated utility, but let me just finish it off anyway. So I'm declaring a new type here. Now this type is actually the type for this structure here. And the way you interpret this type is it's going to be an object where the keys of the object correspond to that. This is just ordinary JavaScript subscripting syntax. I'm picking out the ID property of text. I'm really sorry about that. I don't know why Zoom just keeps kicking me back out and I have to come back in again. If it keeps happening now, I'm just going to have to give up on this, but sorry about that now. Am I still muted? No, I'm not. Okay, so I'm trying to come up with a way of describing this from a TypeScript point of view. That's where the record utility comes in. The keys are of that structure. The values in my map are of this structure. And I suppose, look, rather than looking at the body of this function, that's what record is. That's kind of the main use case for the record utility type. When you want to describe an object where you can state what the nature of the keys in the object are and what the nature of the values are. Yeah, let's just kind of leave it at that, really. And you can look at the example. I don't see you ever using the record utility type in this module anyway, but you may come across it in code that you look at when you read articles about TypeScript. Okay, that was a bit of a struggle. That's all I want to cover in regards to TypeScript, but of course there are lots of other aspects of the language which we won't have time to look at. And go back to the lab and complete the lab. And hopefully that will help you to clarify some of the concepts that we've been, constructs that we've been looking at. I go back to my website. Time. Okay. I want to move into this section. So we've parked TypeScript for now, and I want to take a step closer to looking at the whole world of the AWS cloud platform. Now, there's a lab accompanying this. This is the lab. What this is here is um, those of you that have studied AWS before will probably know this, but those of you that haven't may not. So when you create an AWS account, the account that's created for you is what we refer to as the root user account. And you log into your account using your root user privileges. But it's considered bad practice to log in using your root user credentials kind of on a daily basis. You should only really log into your root user account, if you need to check your budgets or that kind of thing, or your usage over a period of time. If you're doing any kind of development work, then what you should do is create what's called an IAM user, which essentially just gives you a different set of credentials for logging into your AWS account. And the IAM user, then you assign privileges to that IAM user, which would tend to be slower than the privileges of your root user. So what this here does, if you go into it, is it explains the steps to creating an IAM user. And I would strongly advise you all to do that. Okay. This then is a lab based on the topic that I really want to cover, which is this Cloud Development Kit or this CDK kit. So what is this CDK kit all about? Slides. So the context here is I want to develop an application and I want to deploy that application to the AWS cloud. But in order to deploy it, that means I need to create uh, infrastructure on the cloud within my account. Now, that might be something as simple as I need to create an EC2 instance, and then I deploy my application to that EC2 instance, which is exactly what we did, for example, in the Agile module there last semester. We deployed a containerized application. But the creation of the EC2 instance was something that we did manually. Now, we won't be using EC2 at all, but the general point is you want to deploy an application that you've developed locally. You want to deploy it to the cloud, and in our case, to the AWS cloud platform. To do that, though, you first of all need to create the infrastructure, or to phrase it another way, you need to create the relevant resources within your account on the AWS platform so that you can then deploy your application to those resources. The resources might be a compute related resource like EC2 or something like Lambda, which we will be particularly interested in. You may want to create a database. You may want to create a location where you can store files. Let's supposing uploading of images is something that's part of your application. In the case of AWS, that would mean creating an S3 bucket for those of you that have done some AWS development so far. Either way, you need to, before you can actually deploy your application, you need to create the infrastructure or the resources that are required to support your application. Now, how do you go about creating that infrastructure or creating those resources? You could do it manually, but the problem, of course, with doing anything manually is that if you have to do it a number of times, then you may make mistakes or it's not consistent. So whatever approach we use to creating the infrastructure or creating the resources, the approach that we use, we would like it to be uh, consistent and reliable, mainly because it's something that we're going to be doing multiple times during the development life cycle of our application, and possibly during even the production time of our application as well. Now, those of you that have studied anything about AWS at all will know that the AWS cloud is broken up into what are called regions from a global perspective. And if you want to deploy an application to the AWS cloud, well, you've got to decide, first of all, which region am I going to deploy it to? Or maybe you want to actually deploy it to multiple regions because you anticipate that your application's user base will be distributed globally. And so in order to give them the users experience, a good experience from a latency point of view, then you would want to deploy your application to multiple regions. But you've got to create the resources or the infrastructure within each of those regions in order to deploy to each of them. So that's one use case where the actual creation of the infrastructure or creation of the cloud resources is something that you will need to do more than once. And therefore, you've got to make sure that whatever approach you use, it has to be consistent and reliable, that you're creating the exact same infrastructure in each region. Also, from a development perspective, you may want to have a development environment, a test environment, and a production environment for your application in the cloud. So that means we need to create development infrastructure, test infrastructure, and production infrastructure. And each of those three has to be exact replicas of each other. In other words, you've got to make sure that the way you create them is consistent across the three different types of environments. So both of these are use cases which mean that you will need to, whatever approach you take to creating the infrastructure has to have these characteristics here. Clearly, if you take a manual approach towards achieving that, that's not good because anything manual is prone to errors. Even if you do approach it from a manual approach, you might say, well, if I document the steps that need to be carried out, then that will ensure that if more than one person is responsible for creating the infrastructure, be it across multiple regions or for different environments, then at least everybody will be reading from the same manual. But of course, there may be changes required to the infrastructure, in which case you have got to make sure that you keep that manual up to date and that there aren't multiple copies of the manual floating around the organization where some people are reading the old version of the manual, etc., etc. What we tend to say here is that there's no single source of truth, no single source that everybody uses to manually create the infrastructure. We just lack that, and it just becomes an unmanageable situation if you're talking about documenting it in some sort of document and making sure everybody is using the same document. So a manual approach is not good. We'd prefer an automated approach. And if we do take an automated approach, then what we are doing is we're implementing the creation of the infrastructure using code. So the acronym we use is infrastructure as code. code is actually going to be describing the infrastructure or resources that we need to have created in the cloud. And we somehow run this code. And of course, the beauty of code is that, uh, well, we'll come on to that maybe in the next slide. So this infrastructure as code acronym um, is where this cloud development kit comes into play. The cloud development kit, the AWS cloud development kit, is a framework provided by the AWS organization, which allows us to achieve this infrastructure as code approach toward creating cloud resources. And the advantages, of course, at the end of the day, it's just code. So we can store that code in a GitHub repository. We can subject it to version control using Git. And we know what the beauty of using a version control is. If we make errors in our code, when we run the code, if it causes the application to crash, which in this case would mean it doesn't actually it doesn't create all of the infrastructure for us, then of course the great thing is that we can roll back the GitHub repository to a previous stage when it worked properly and then start doing our debugging. So we get all the benefits associated with version control and version control tools and repositories and all of that. We get all of that for free, if you like, by implementing our infrastructure creation in an automated way using the infrastructure as code approach. Okay, and so when I'm talking about infrastructure or cloud resources, they both kind of mean the same thing. For example, I'm talking about things like this: creating an S3 bucket, creating an EC2 instance, creating an SQS queue, if you know what an SQS queue is, creating a DynamoDB database, and so on and so forth. Okay, so we want to be able to somehow achieve this codification of the creation of infrastructure. And it has been something, it's been an objective of the software development community for quite a while. And what I'm showing you over the next couple of slides is essentially the history of this infrastructure as code idea. Okay, and I think it's always useful to have a sense of how we got to where we are, kind of. So the very first generation, the very first approach towards this infrastructure as code, it kind of looked as follows, right? Now you won't be able to read this here, but what we did back then, in kind of the first generation of infrastructure as code, was we wrote Python scripts. So what I'm showing you here now is on the right, these are some of the AWS services. Okay, so maybe we've got the EC2 service, the S3 service, and so on and so forth. And these services are what we need to talk to in order to create our resources. So we would talk to the EC2 service in order to create an EC2 instance. We talk to the S3 service in order to create an S3 bucket, and so on and so forth. These services actually, what AWS did was they provided a web API interface to each of these services. That means we can communicate with them over the network. And the purpose of the communication might be to ask the service to create a particular resource for us. Now, what the AWS people also did was they provided a software development kit or an SDK. Initially, they just provided one in Python. So if you can imagine, we have an SDK kit, just a software library, which we can write code that uses that kit. And what the kit does is, the SDK does is, it actually takes care of the communication with the relevant service. Okay, so what we do then is we write a script which is using the SDK. The Python was the very first SDK, and it's called Boto 3. You may have played with it a little bit, those of you that have studied this stuff before. So this Python script here is using this SDK. Can I get SDK in? SDK. Sorry about that. It's the best I can do. Which is just a library, as I said. The Python script is using the SDK for the purpose of communicating with whatever services you want to use in order to create your resources. And that worked really well initially. So we wrote our Python script and we executed it, and it hopefully created the resources. And we'd have to check manually that it did. Now, there were lots of problems though with that approach, and I'm mentioning some of them here. One is what happens if an API call fails. So what I mean by that is, okay, your Python script invokes a particular method of the SDK, and let's suppose the purpose of the method is to create an EC2 instance. The SDK then sends the HTTP requests, there are probably going to be more than one, across the network to the EC2 service. But of course, networks being networks, maybe some of those calls don't get to their destination, some errors occur. Now, the problem is that our Python script here, unless we've written in very sophisticated error handling and maybe loops to retry a number of times before it gives up, unless we've really programmed all of that into our Python script, then there's no way of knowing once the Python script completes, there's no way of knowing for certain were all of my resources actually created, other than checking it manually, of course. So that was one problem. Another problem might be was when do I know when a resource is actually ready? You know, the creation of these resources by the AWS services, they're going to take time. Okay, we're talking about seconds or milliseconds. But if there's some part of your script down here which is dependent or assumes that a resource that it wanted created earlier on has to be ready to receive more configuration, let's say, configuration settings. So there's code down here. Again, it's using the SDK, but it's asking the SDK now to change some of the configuration of a resource that it has created up here. But you know, the time difference between the code here and the code here might be milliseconds, but it might take the actual service over here a couple of seconds before it actually creates the resource. So we've got a problem there as well. And thirdly, of course, is okay, let's suppose you run your script and everything works perfectly. It creates all the resources over here. But then if I want to change the configuration of some of those resources, I've essentially got to write a completely new script. And the new script now is based on the fact that my resources already exist, but I want to change that configuration. So really, this approach only works if you only want to create a set of resources and you never want to change them again. And that's very rare. But it was the first attempt anyway at this infrastructure as code. So this Python script is the purpose of it is to create infrastructure resources on the AWS cloud in an automated way. Where are we on time? Okay, keep going a little bit. Now, the next thing, the second generation of this infrastructure as code idea comes in the form of what are called resource provisioning engines. So this was really, these resource provisioning engines was a response by the cloud providers, e.g. AWS, to address the problems that I was mentioning on the previous slide. Now, what a resource provisioning engine is another service. In the case of AWS, it's a service called CloudFormation. It's a service whose only purpose is to create infrastructure resources for you. Okay, so it essentially now takes care of talking to the other services like EC2 and S3 and so on and so forth. It's responsible for doing that communication. On the previous slide, our Python script via the SDK was talking to these services. Now, CloudFormation is taking care of all of that, and it's doing it in a very sophisticated way. It deals with things like waiting to ensure that a resource has been created before it tries to change its configuration, or creating the resources in the correct order. What you do then as a developer in the second generation is you write what's called in the language of AWS anyway, you write a CloudFormation template. That's just a document, it can be either in JSON or YAML. And in this document, you describe the infrastructure that you want created. Okay, you're not describing the steps involved in creating this infrastructure. You're just describing the infrastructure that you want. If you like, you're describing the end state, and you don't have to worry about things like creating the infrastructure in the correct order or anything like that. You're describing, and let's use the language that we use in infrastructure as code. In this document, you are describing the state of the infrastructure that you want to have created over here. So this CloudFormation template, you give that, you upload that to the CloudFormation service, and it takes care then of all of the messy stuff associated with communicating with the individual services for the purpose of creating the infrastructure that you have declared here. So this YAML stroke JSON document we refer to as a CloudFormation template. Now, a company called HashiCorp, what they did was they created this document here can be quite long, like hundreds of lines, and it's all YAML and JSON. So, from a typing perspective, it's error prone. But of course, the CloudFormation will tell you if there are errors in your template and you make changes to it. But, it's quite tedious to write these documents. What this company called HashiCorp did was they created a more sophisticated version of these templates. By sophisticated, I mean you don't have to write as much syntax. In the case of HashiCorp, we're not using raw JSON or YAML. We're using a language called the CloudFormation language. The configuration language, or HCL, HashiCorp configuration language. It's still YAML, but it's not as much syntax as what you would have to do up here. Okay, that's just, we're not too interested in that. This is the one that we're kind of really interested in. Although this one down here is extremely popular. If you've heard of Terraform at all, Terraform is the tool that you use for writing this HCL documents. The main point anyway is this thing here is what we're calling the resource provisioning engine. That was generation number 2. So as developers, we now write these templates. We give them to the CloudFormation service, which is our resource provisioning engine, and it takes care of talking to the other AWS services for the purpose of creating our infrastructure. And it was great, in terms of if you wanted to update your infrastructure, which was one of the problems with the first generation, If you wanted to update, all you did was, if I go back again, you went back to this document and you just made the relevant changes to uh, the configuration of the resources. That's really what we tend to mean by update. You want to change the configuration of resources or indeed add new resources. But you changed this document and you gave that document now back to CloudFormation. And what CloudFormation does is it can compare this new state with the current state of your resources, and it actually works out what changes need to happen to the current state of your resources in order to make it consistent with the new state that you're described here. So that was great. It was easy to update the state of your infrastructure. It was highly kind of consistent and reliable because, again, if I go back, if I provide this template to the CloudFormation service in various regions within the AWS cloud, then I can be guaranteed that the CloudFormation service in each region will create the exact same infrastructure as every other region. And also, if I want to create a development version of this infrastructure and a test version, then I just give it to the AWS. I give the document a different name, and it will create multiple copies, if you like, of the infrastructure for me. The downside was, you are writing YAML or JSON, which is not a developer-friendly syntax. There are no kind of abstractions available to you. You're dealing with very low-level detail in these templates. This is another way of looking at the evolution. Okay, so this is really telling the same story now as the previous two slides, if you like. But when I saw this image, I thought it was actually quite nice. So the way you kind of interpret this image is that as follows: working from the inside out. AWS provided Web API interfaces to its various services, and I mentioned that earlier on. Okay, provided a Web API. That means we could communicate with it because we know what a Web API is. It also provided a software development kit, and that's what we were using in our Python scripts. These two here kind of are generation one. In generation one, what we did was write a Python script that used the SDK, or indeed there were SDKs available in other languages as well, but they all had the same problems really, or issues with them. Then our CloudFormation, or our resource provisioning engine, this was generation number 2. And as I've kind of indicated, the CloudFormation service, it does actually use the SDK. So it's still using that route or using these kind of foundations. Critically though, the CloudFormation service, what it's big into is state management. State here kind of means what is the configuration settings for the various resources that you have had created for you. What are their configuration settings? That's what we mean by the state of your infrastructure. And the CloudFormation service managed the state for you. Okay, so CloudFormation came about around 2011. I'm seeing here, I don't have a date for the SDKs, but you're talking about maybe at least 5, if not longer, years prior to that. Enter generation 3, the third generation of this infrastructure as code idea. And one tool that comes under the third generation is the Cloud Development Kit, or the CDK. There are many others though. The CDK was provided by are developed by AWS themselves, so it's not open source as such. There are open source competitors to it. So this was the CDK was first released around 2019. So we're talking about 8 years after CloudFormation. And in the visual here, I'm showing you that the CDK kind of builds on the second generation, obviously enough. The second generation being the resource provisioning engine, e.g. CloudFormation. CloudFormation was big into state management, as I said, but in terms of how you interacted with CloudFormation, you wrote your YAML documents, your templates. Those templates were either written in YAML or JSON, and that, as a language, we would say that is very much a declarative style of programming, if you could call it programming, okay? But it is declarative. Whereas with the Cloud Development Kit and other frameworks that are competing with it, you actually write your infrastructure code using a procedural language. Here you're writing it in a declarative language, YAML or JSON. Here you're using a procedural language, like all of the languages that we are familiar with, like Python, C#, TypeScript, etc. I'm mentioning some of them over here. So the actual code that you're writing is code that is describing infrastructure that you want to have created. Okay, and as well, the CDK is big into state management as well. But in fact, what it really does is it kind of leverages CloudFormation. So the key difference between this part of the diagram and here is that we're using procedural languages as our infrastructure as code tool. Here we're using declarative languages, YAML and JSON. So arguably there's a much better developer experience when you're using this third generation of infrastructure as code tools. So we are going to focus on the CDK specifically, but as I said, there are other competitors to it. And I am probably out of time at this stage. Okay. I will stop the lecture there. I guess, as usual, I don't give people opportunities to ask questions, but you're not in the habit of doing it anyway, and that's okay. So from a lab's perspective, you can certainly finish off the TypeScript lab. And I would also not so much encourage you, but require you to complete this process here for creating an IAM user for yourselves, for your AWS account. You can have a go with this lab. It's quite short, it's very prescriptive, but we certainly haven't talked about it at all. Right. Are there any closing questions before I finish? No. Okay. I will actually turn up in the allocated lab rooms for tomorrow morning, but it's kind of optional as to whether you want to come along or not. I will also monitor Slack, so I'm allowing people essentially to work remotely during those lab hours. And if you're having issues with the TypeScript lab, then post them on Slack and I'll monitor the Slack channels during the lab hours. Right, we'll leave it at that and I'll talk to you either tomorrow or next week. Thanks, bye-bye.